What was learned in the previous classes? That is the lesson 11, that is force and pressure. So due to the force, what is the definition of force, and what are the effects of force, what are the types of force, how will the forces arises. You have learned in the previous classes, that is what is force. In today's class, we will discuss about the definition of pressure, example of pressure, application of pressure, and pressure exerted by liquids and pressure exerted by gases and atmospheric pressure. That all are the terms in the today class we will learn about. We will learn that. Okay. So first, what is pressure? What is pressure? Pressure is nothing but the effect of force. Pressure is nothing but that is the effect of force. Force is applied to the particular area, the pressure will be arises. So pressure is nothing but pressure P is equal to force by unit area. So force is acting per unit area, not a unit area, it's a particular area. Force by acting area, this is called pressure. So pressure will be easily arise by applying force. Okay. So what's the unit of pressure? That is the unit of force is Newton and unit of area is meter square. So this is the unit of pressure. So unit of pressure is equal to Newton per meter square. R simply is written down in Newton meter per minus 2. R the unit of pressure is Pascal. Pascal is the unit of pressure. It's named after some scientist, that is Amélie Pascal. Amélie Pascal will be explaining the terms of pressure. So here him name it will be for the pressure unit of pressure. Okay. So that is the unit of pressure is Newton per meter square, Newton meter per minus 2 R Pascal. So what is the definition of pressure? Force by unit area. What's the unit of pressure? That is Newton per meter square, Newton meter per minus 2 R Pascal. So I will give some example, and then always the pressure will be the inversely proportional to the area. The pressure depends upon the area, it will be inversely proportional to the area. So area increases, pressure increases due to the area decreases. Area decrease panna pressure increase agum. Area increase panna pressure will be reduces. So area increases, pressure decreases, area decreases, the pressure increases. So this is the only one, it will be depends upon each other. So pressure will be inversely proportional to the area. So I will give some example for that to explain the pressure. First you take the two thumb pins. So one thumb pin having a sharp tip edge and another pin having the blunt tip edge. Okay, the edge is blunt one and edge is sharp one. The two pins it will be tried to insert on their wooden board. So which pin it will be easily insert to the wooden board? One pin having the sharp edge, it will be easily inserted on their wooden board. Okay, why? The sharp pin having a greater pressure because the force is by applying in a little bit area. So the force is applying in a small area, the pressure will be increases. Due to the concept this is the pressure, it will be inversely proportional to the area. So area decrease automatically pressure increase agum. Pin tip area portion, force act area portion is very small. So that why the pressure will be increases. So easily that pin it will be easily inserted on the wooden board. And I will give another one example for that. Take the two keep of cotton and the two sides and and take also the two boards. One is made up of wood and another one is made up of iron. So the wooden board it will be keep the wooden board on the keep of the cotton, as well as the keep the iron block it will be keep on the keep of cotton. Which one depress easily the keep of cotton? Iron board or wooden board? Iron board. So iron block little bit heavier than the wooden block. So it will be easily depress the keep of cotton. So this is the iron board having the high pressure is comparable to the wooden board, wooden block or wooden board. So this is the another one example for pressure. And next we will go for the application of pressure. Applications of pressure. Applications of pressures in our day-to-day life, the pressure will be used in various ways. First, I will give various examples one by one. First, taking the cutting instruments, the knife and scissors, having the one side is a very sharp edge. At the sharp sides, the pressure will be increases because they are having the force giving the force on their sharp sides in a little bit area. So it's easily the force will be applying in a force it will be used in a sharp edge point. The pressure it will be increases. So easily the pressure increases, easily cut the vegetables and cut the papers or cloth, anything. So first one is cutting instruments. Second one is hammer and nail on wooden board. Hammer and nail on wooden board means, so nail having sharp edge is one side, so the pressure will be increases at the side, so easily the nail will be easily inserted on their wooden board. This is the second point. And third one is porters. Porters always carrying the heavy load on their head. How is it possible? The heavy load, the bottom of the heavy load will be occupying a large area, so that at the wider area the pressure will be easily reduces, so lower pressure will be applied on their head, so easily the porters easily carry the heavy loads due to the lower pressure. Okay, that is the third point. And fourth point, one girl carry a thin strap bag, shoulder bag. So another one girl carry a wider strap handbag. Okay, which one will be giving the greatest pain to their shoulder? The wider bag, wider strap handbag. So apply the lower pressure on their shoulder, on his and her shoulder. So easily she carry the weight or but thin strap handbag. So applying a little bit area, so applying the high pressure on her shoulder. So it will be definitely she hurt pain. So திக் கொஞ்சம் பேக்கில் ஸ்ட்ராப்பர் வந்து பெருசாக இருந்தால் மட்டும்தான் ப்ரெஷர் வந்து அதிகமாக இல்லாமல் கம்மியாக இருக்கும். ஸோ ஈஸிலி நம்ம பேக்கை கேரி பண்ண முடியும். திஸ் இஸ் த fourth one. And fifth one, elephants. Elephants is a very huge animal, so having the greater weight, but their legs is not a tip point, it will be in a broad bottom, so that the broad bottom is applying the lower pressure on their surface, so easily walk on their land. Then as well as the camel having badder feet. The badder feet will be easily move on the sand, so badder feet will be giving the gripness to the surface for a camel, so easily walk on their land. And then ice persons is moving by using the skis. Normally the one person will be walk on the ice area, definitely it will be slippery. So using the skis, it will be giving the wider surface to touch the iceberg, so the wider area you are applying the lowest pressure, so easily walk on the icebergs. So the more and more example for applications of pressures. And next we will go for the applications of pressure. Next we will go for the pressure exerted by liquids. Okay, pressure exerted by the liquids. How will you pressure exerted by the liquids? Pressure exerted by liquids. Liquids also giving the pressure. Okay, liquids also excites the pressure. So I will give the two examples. So first one is according to the pressure exerted by the liquids is completely put upon the height of the liquid column. So height of the liquid column means we will choose the tall transparent container. One side is open, another one side we will fix one balloon, and take another one transparent glass tube, and I fix one balloon at the one side, and one side is open. Suppose some water on the first bore is a little bit water on the glass transparent tube, and the balloon it will be bulged in small. Okay, but at the bore there's some water to the more water in the second transparent tube, the balloon it will be bulged more. Why? So due to the height of the liquid column, this liquid column height is very low, so giving the lowest pressure to the balloon, so the balloon is bulged in small. But the second part, the water will be in the glass tube will be greater, so the giving the greatest force to the balloon, so the balloon it will be easily bulged in large size. This is the pressure exerted by the liquids. It depends upon the height of the liquid column. So height will be increases, automatically the pressure it will be increases, and easily it will be exerted the pressure. Okay. Second one will be taken in the two cases. One is two cases there. So one is pressure increases with increasing depth. Pressure increases with increasing depth. Okay. Second one, pressure is equal at equal depth. Equal at equal depth. The same as same depth. So first one is the same at same depth is all the same is equal at equal depth. So pressure is increases with increasing depth means you put the 3 holes in one, take one water bottle, you put 3 holes in take one water bottle, take one water bottle, you put 3 holes at the bottom, at the middle, at the top, we fill the water inside to the bottle, you fill the water into the water bottle, the first hole applying the force in a minimum, and second hole the pressure it will be little bit greater than the first one, so it will be the water will be rushed out in this side, and third one have a greater pressure is comparable to the first 2 holes, so the water will be rushed in various little bit distance will be greater than the first 2 one. So okay, so the pressure will be increasing due to the depth. So depth automatically increases, the pressure always at the bottom to be increases. The first point, the height is there in the first part, so the pressure will be in lower comparable to the lower 2 points. So the last point having a higher pressure because the depth it will be high, so easily the water will be exerted from their water bottle due to the high pressure. So this is the first case, and second one, pressure is equal at equal depth. I will explain this topic with an example. So take one water bottle and take this water bottle I filled with water. I fill the water in the water bottle. Already I put the 3 holes in the air water bottle. So giving the 3 holes the pressure it will be equal at the same depth because 3 holes in the same depth. So 3 holes the water will be the pressure is exerted at the 3 holes, it will be in equal. So equal 3 depth ku neenga hole potrindinga appadina 3 hole la water vandu equal varum because 3 holes in the same depth, so easily the water will be rushed out at the 3 sides having the equal pressure. Okay, and then so the 2 activities there. So one is pressure increases with the increasing depth, second one is pressure is equal to the equal depth. So equal depth irundhuchina pressure equal irukum, but various depth irundhuchina depth increase ஆக pressure increase ஆகும். This is the 2 activities. And go for the next one, pressure exerted by gases. Pressure exerted by gases. Pressure exerted by gases, take one container filled with water, take one container filled with water, take one medicine dropper. The medicine dropper is will be easily inserted to the water surface. Medicine dropper it will be inserted to the water surface. Medicine dropper is easily inserted to the water. It will be inserted to the water surface. Giving the press to the top side of the medicine dropper. The inside air it will be expelled to the water surface. The inside air, you press the top side of the medicine dropper, air it will be escaped from the air from the dropper to the water surface. So definitely it will be create some bubbles. So first bubble is very small and it will be little bit great and great and great. So reach their water surface, the bubbles reach their water surface, the bubbles it will be very bigger. And suppose it will be reach the water surface, it will be burst because the bubbles it will be, the pressure will be greater in the water bubbles. So reach their atmospheric pressure is giving to the liquid air pressure, so it will be definitely burst. Nothing but நீங்கள் மெடிசன் ட்ராப்பராக உள்ள வாட்டருக்குள்ளே கொண்டு போயிட்டு ப்ரெஸ் பண்ணோடனே வாட்டர் பபிள்ஸ் வந்து ஃபார்ம் ஆகும், ஏர் பபிள்ஸ் வந்து ஃபார்ம் ஆகும். அந்த ஏர் பபிள் வெளியில் வரையும் அட்மாஸ்பியரிக் ப்ரெஷர்னால மேலே கூட அந்த ஏர் பபிளில் உள்ள ப்ரெஷர் கம்மியாக இருக்கனால அட்மாஸ்பியரிக் ப்ரெஷர்னால என்ன செய்யும், அந்த பபிள் இட் வில் பி பர்ஸ்ட் அவுட். ஸோ திஸ் இஸ் த ப்ரெஷர் எக்ஸடட் பை கேஸஸ். உள்ள இருக்கக்கூடிய கேஸ் தான் என்ன செய்யுது, உள்ள ப்ரெஷர் அப்ளை பண்ணுது, அதனால தான் பபிள் ஃபார்ம் ஆகுது. திஸ் இஸ் த ப்ரெஷர் எக்ஸடட் பை கேஸஸ். அண்ட் நெக்ஸ்ட் that is atmospheric pressure. What is the atmospheric pressure? What is atmosphere? What is that atmosphere? The gas is enveloped in the surrounding surface. நம்ம சுற்றி இருக்கக்கூடிய கேஸோடைய சரௌண்டிங் பேர் தான் அது atmosphere. Atmosphere is nothing but the gas enveloped in the surrounding surface. That is the atmosphere. The pressure is exerted by the atmosphere is atmospheric pressure. Moreover, atmospheric pressure will be measured, can be measured by using barometer. So, okay, so I will give some example for the atmospheric pressure. First, you take one tumbler. Take one tumbler filled with water. Take one tumbler is filled with water, and take one tumbler is filled with water, and take one cardboard, and you will fix the top side of the glass tumbler, and you will use one hand you will hold the water bottle, and another one hand you use to press the cardboard on the top side. Okay, then this time you turn the water bottle, and you remove your hand on the cardboard. It will be easily stick on to the top of the glass bottle. How is it possible? The inside of the water surface having some pressure, it will be lower than the atmospheric pressure. So atmospheric pressure is giving the force to the wooden board, so easily stick on to the mouth point of the tumbler. So easily it will be know that the atmospheric pressure. So atmosphere exerts some pressure on the something. So I will give another one example. Take one airtight water container. The container is filled with water. The container to be heated by applying heat by using the candle or any flames. So once few minutes later the water to be boiled in the airtight container. That time the flame it will be off, and then is removed from the flame. The airtight container is closed with the lid. After that we will pour the cold water on the top side of the airtight container. What will happen? The airtight container it will be squeezed, it will be compressed is the inside. Why? So inside airtight container having a hot air. So you pouring the cold water, the hot air will be condensed to make the water. So some air column it will be presented. That the air column, that the vacuum space, no air pressure is there. So outside air pressure will be acting on the air inside, comparable to the lower pressure is the inside of the air container. So easily depressed. வெளியில் இருக்கக்கூடிய atmospheric pressure உள்ள இருக்கக்கூடிய pressure விட அதிகமாக இருக்கிறனால it will be depressed inside. So that is this is the example for atmospheric pressure. What are the applications of atmosphere air pressure? I will give the more and more daily life example for explaining the atmospheric pressure. So sometimes you went to in the mountain trip. That time you felt vomiting sensation in the mountain trip. Why? So vomiting sensation you must create in the mountain having the greater altitude, having the lower pressure. Scale and the ground and the mela poga, and that the mountain sides are having the high altitude, that the part having the lowest atmospheric pressure comparable to air or body pressure. So body having some pressure. Inside your body pressure it will be greater comparable to the atmospheric pressure. If your liquid inside in your body it will be immediately it will be rushed out. This is the same way the nose will be bleeding. Sometimes some persons are having the nose bleeding in the air to moving the high altitude because atmospheric pressure is very low comparable to air body pressure. And then as well as the ear it will be pop up to moving the air mountain trip or moving in the high hill station area. So high hill station area having the lowest pressure comparable to our body pressure. So your eardrum it will be moving outside, it will be balance the pressure in being the inside and outside of the body. வெளியில் இருக்கக்கூடிய ப்ரெஷரையும் உள்ள இருக்கக்கூடிய ப்ரெஷரையும் பேலன்ஸ் பண்ணுறதுக்காண்டி இயரில் இருக்கக்கூடிய இயர் ட்ரம் ஜஸ்ட் இட் வில் பி மூவிங் அவுட் சைட். ஸோ இந்த இயர் இட் பி பாப்பிங் at a high altitude sites. Okay, so more and more example I will give another one example. You use a star to chuck a cool drinks. So using the straw, you insert the gas by using your mouth, the pressure. So liquid pressure is greater, it will be easily inserted the straw, so easily you will drink. ஜூஸ் குடிக்கும்போது ஜூஸில் இருக்கக்கூடிய ஸ்ட்ரா யூஸ் பண்ணி குடிப்பீங்க. அந்த ஸ்ட்ராவில் இருக்கக்கூடிய ப்ரெஷர் நீங்கள் செக் பண்ண உடனே உள்ள இருக்கக்கூடிய ப்ரெஷர் will be low comparable to the liquid pressure. So liquid pressure is greater, so easily the liquid is inserted on the straw. So easily you have to drink the cool drink. Okay, this is more and more applications for atmospheric pressure. Atmospheric pressure is nothing but atmosphere is giving the exert the pressure on the air body, on the air something or anything. So Otto von Curie, that is a German scientist, did one experiment for that to explain the atmospheric pressure. Otto von Curie is a German scientist. He is a German scientist. He did one experiment to explain the atmospheric pressure. He took two big hemispheres. It will be fixed one by one. It will be contact with one another to making a joint. So two hemispheres will be fixed with one another. After the fixing, remove the air inside of the cylinders, hemispheres by using the vacuum pump and two sets of hoses. It will be used to pull the cylinders, two hemispheres, to try to pull the two hemispheres, but that the hoses failed to pull the two hemispheres. Why? Because the two hemisphere does not have any air, so no pressure is there. But atmospheric pressure is very much greater comparable to the inside pressure of the two hemispheres. So atmospheric pressure does not remove the joint between the two hemispheres. And the hemisphere இப்படி ஜாயின் பண்ணியிருக்காங்க. உள்ளே வந்து நம்ம உள்ளே இருக்கக்கூடிய ஏரை நம்ம வெளியில் பம்ப் பண்ணி எடுத்துகிறோம். ஸோ உள்ளே இருக்க ப்ரெஷர் வந்து லோவாக இருக்கும் கம்பேரபிள் டு த atmospheric pressure. So atmospheric pressure will be greater than their inside pressure. So atmospheric pressure cannot remove to the fixing of two hemispheres. So does not easy to remove the fixing of two hemispheres. So that the experiment will be clearly explained what the atmospheric pressure to exert the pressure. How with the atmosphere exert the pressures. So what was learned in this class? What is the definition of pressure? What are the examples of pressure? And what are the applications of pressure? How the pressure exerted by liquids, how the pressure exerted by gases, and atmospheric pressure, and what are the examples of atmospheric pressure, and one experiment by Otto von Curie. That all are the very very easily. I hope that you understood all the things. So okay, today home assignment is learn the applications of pressure. So what is the homework for today, ma? Learn the applications of pressure. Okay, thank you.